So everyone's building AI agents, right? Giving them access to email, Slack, calendars, databases, basically letting them take real actions in your system. And the next major AI failure isn't going to be some hacker breaking in. It's going to be your AI sending an email because the thread seemed like you approved it, or updating a customer record because the old data looked stale, or opening a pull request because the test passed and it seemed done. And here's the thing that makes this a bit unfortunate. The AI didn't misbehave. It did exactly what it thought you wanted, just acted a little past where it should have stopped. Lindy, the AI agent company, hit this exact problem publicly. And the way they fixed it is something every company building agents needs to understand, because you can't prompt your way out of this, and human approval doesn't scale. Let me show you what's exactly happening in the architecture that's working. Here's the thing people don't realize about AI agents. When you're using ChatGPT or Claude in chat, you're in a suggestion space. The AI drafts something, proposes something, summarizes something. If it's wrong, you just reject it. The cost is local. It's just you and the AI, but production AI agents live in consequence space. They can notify someone, expose private information, change a shared record, trigger a workflow, spend money. And that moves a question to the center that chat demos never really had the answer. Who decides whether the agent should be allowed to act? So in the instance of Lindy, because they're the cleanest public example of this, Lindy is a multi-channel AI agent product. You give it access to your email, your Slack, your calendar, and your CRM, and it automates this stuff for you. And they hit a failure mode that every production agent system will eventually face. Their agents would take actions that seemed reasonable in isolation, but crossed permission boundaries. People in the support forums reporting things like, AI gets stuck repeatedly clicking a button. AI doesn't stop when you tell it to stop. AI moves on to the next client without permission. Agent loops through actions it shouldn't be doing. Not malicious, not hacked, just acting a little bit past where it should have stopped. So the obvious answer most people try first is just tell the AI to be more careful. Add safety instructions to your prompt. Tell it to double check. Tell it to act before taking risky actions. And that doesn't work. Here's why. A simple prompt can't pursue task and police that task at the same time. Think about what you're asking the model to do. You're saying complete this task efficiently, but also constantly second guess yourself. Be proactive, but also overly cautious. Take action, but also don't take action. Those are conflicting optimization pressures, and the model will always optimize for task completion, because that's exactly what it's being measured on. That's what gets reinforced. So the safety instructions, they get deprioritized, ignored, rationalized away when the task seems important. You cannot prompt your way out of this problem because it's structural. So if the prompts don't work, what about human approval? Just require a human to review every action before it executes. Problem solved, right? Well, not really, because approval models ruin the workflow. Here's what actually happens. Users click through out of habit. They get approval fatigue. By the time you reviewed your 50th agent decision today, you're rubber stamping. You're not actually reading them anymore. Option 2, users stop using the system entirely. Too much friction. The whole point of an agent is to save time. If you're spending 20 minutes a day approving every little thing, you just turn it off. And here's the bigger problem. Human attention doesn't scale to dozens of agents. If one agent takes 20 decisions a day, that's manageable. But 10 agents, that's 200 decisions. 50 agents, that's thousands. You can't scale human in the loop to production agent deployments. The math just doesn't work, so prompts don't work. Manual approval just doesn't really work, so what does? The answer that's actually working is architectural. A separate model called the judge model. Not a prompt, not a human, a specialized AI whose only job is to evaluate whether proposed actions should be allowed. And this is what Lindy and other production agent companies have figured out. Here's how it works. The actor agent proposes an action. I'm going to send this email to this customer. The judge model evaluates it before execution. The judge looks at the action, the context, the permissions, and the risk level. The judge then returns a decision, not just a yes or no. We'll get into that in a second. Only approved actions are executed. And here's why this works when prompts don't. The actor and the judge have different jobs. The actor's job, complete the task, be helpful, and get things done. The judge's job, enforce boundaries, assess risk, and protect the system. No conflicting objectives, each model is optimized for one thing. Now here's the interesting part. The judge doesn't just return yes or no. That's too simple. Instead, it classifies actions into 4 risk buckets and returns 4 possible decisions. Bucket 1, safe and auto-approve. This one has read-only operations, internal queries, logging, and summarizing. Decision, approve, execute immediately. Bucket number 2, low risk, log, and execute. Limited scope actions, internal notifications, non-destructive writes, decision, approve with modification. Maybe redact sensitive parts, summarize instead of full access. Bucket number 3, medium risk human review. actions affecting shared resources, external communications, data modifications, the decision, request, human review. Pause, route to review or resume work after approval. And bucket number 4, high risk, block or escalate, irreversible operations, delete, publish, spend money, access to sensitive data, permission changes, the decision, deny, block, log, escalate if pattern is detected. So instead of can I do this, yes or no, it's can I do this exactly as proposed, or should I modify it? Or is this completely off limits? That's how you get nuanced judgment without requiring human review on every action. And here's the critical part. Where the judge sits in your architecture, it operates at the action boundary. That's after the agent has formed intent, but before the system executes. There's actually 8 layers here. The agent identity, who is this agent? The delegation, what authority was it given? Resource access, what can it see? Tool access, what functions can it call? Action rights, can it actually do this? The judge sits right here, evaluating proposed actions. Runtime policy, dynamic constraints, and audibility, logging everything. The judge is the gatekeeper between intent and execution. This isn't just theory. There's academic research backing this up. Cisco published a paper on uncertainty-aware risk adaptive access control for agentic systems using LLM judge TBAC model. That was a mouthful. They showed that LLM judges can synthesize just-in-time policies for novel tasks, meaning actions that the agents never tried before that you don't have explicit rules for. And companies are implementing this in production. Lindy fixed their permission issues with this kind of architecture. JP Morgan is using the judge models for financial agent workflows, and OpenAI's own agent projects use multi-model consensus judging. This is the pattern that's working. So if you're building agents right now or think about deploying them in your own company, here's what you need to understand. This is not something that you could bolt on later. The judge layer is architectural. You either need to build it from the start or you rebuild your whole system later. What you actually need to implement is 1. Separate judge model does not have to be as powerful as your actor. It can be smaller and faster, just needs to be specialized for risk assessment. And 2, action classification system. There's 4 buckets. Every proposed action gets classified before execution. 3, decision logic approve. Modify, review, or deny, not just a yes or no. 4, audit trails log every proposal, every decision, and every execution. You need forensics when something goes wrong. 5, human review queue for the medium risk actions that need human eyes, but only those, not everything. And here's the thing. 95% of the decisions should be handled automatically by the judge. Humans only review high risk or high uncertainty actions. That's how you scale. Human attention becomes a scarce resource when you allocate strategically. I want to run this back a little bit because everyone's racing to make agents more capable, more autonomous, and more powerful. But almost nobody's building control layer those agents need. And the companies that don't figure this out, they're going to have a very public failure. An agent that emails your entire customer list by mistake, an agent that deletes production data because it looked unused, or an agent that shares confidential information because the context seemed to allow it, not because the agent was malicious, but it was helpful. The companies that architect this from the start, like Lindy did after they hit it, those companies will be fine. Their agents will be reliable, trustworthy, safe to deploy at scale, but the ones that treat it like this is a, well, we'll figure it out later problem, they're the ones you will read about when things go wrong. So here's my question for you. Are you building AI agents right now? Have you thought about where the judge sits in your architecture? Or are you still trying to solve this with better prompts? Drop a comment below, let's talk about it. Because this is the AI security problem no one's really discussing yet, but everyone is about to hit it. And the difference between we built this right and we built this to rebuild everything is whether you understand this pattern before you deploy it. If you enjoyed this video, don't forget to like and subscribe. I try to cover this regularly. And the last thing is do more, never give up, and always stay humble. See you in the next one.